I created a design for an artificial lung. So you can see here this would be a servo with a standard arm, and when the servo turns counterclockwise, it will pinch off this tube. Now, this tube will lead up to the mouth and nose. So it will intake air when this artificial lung opens up. It's an accordion style lung, air pump. So it will open up, which will draw in air, and when it's opening up, drawing in air, this will be turned clockwise, pinching off the vent tube. Okay, so the vent tube's off, the pressure intake tube is on. It will suck in air into here, filling this. Then this will shut off, freeing the vent. Once the vent's freed and the pressure intake is pinched off, then this will close. It will push air into all the cavities. I can have many, many tubes going throughout the whole robot, but this is an enclosed area. Just demonstrating a simple version of how this will work. So this will close, forcing air through. As the volume of this decreases, the air has to go somewhere. That's pinched off, so it can only go through here. The fresh, cool air will blow through here. This hot air, where all the motors are or whatever, will get forced out as the fresh air enters. So it will completely replace all the air in here. The hot air will come up through the vent line with force, because the volume of the lung is increasing the volume of here, putting pressure on the outsides, and the atmospheric pressure within all the enclosed areas will force the air up through the vent line. The vent line will go through the mouth and nose. So it's going to be really funny. The robot will actually be breathing out hot air just like a human when you hold your hand in front of your breath. And if it were outside on a cold day, you'll actually be able to see steam coming out of its mouth just like a person. It'll look really creepy. And also the breathing, I imagine, could make the robot's chest come in and out, or its stomach come in and out, and that will look incredible because it will be very human-like. So I'm really excited about that. And then I did another drawing. So here's just the same accordion lung, and you can see this is a servo, and okay, you can ignore that. That was the original pincher design. There's going to be one on the top and bottom. I improved that with this, where it can just shut off the two, so you don't need a pincher down here. But this shows you have a servo here. It's connected to this wall of the lung. It pulls that way as it turns counterclockwise, and that draws this wall shut. And then the other string comes all the way around, and as it turns counterclockwise, it frees up that one, so this one will loosen as the wall comes in. So this won't interfere with the pulling. Now, when it turns clockwise, since it's connected here, it will draw this string this way and that string that way. So it will be freeing up this wall on this string, while at the same time this string is wrapping around this pole and coming back this way. So as it turns clockwise, this string draws around here and it pulls this wall out. So if you turn this servo clockwise, the wall comes out. If you turn it counterclockwise, the wall goes in. So just with a single servo, you can power the artificial lung. So I thought that was really cool.